Okay, hi, welcome back to our Zoom record session number 7, right? This is session number 7. So we are going to look at spatial visualization. So there'll be different kinds of skills that we can use to solve area and parameter problems. But today we will just look at two kinds of skills, right? Two types of skills. So what are the two types? So let's look at the first example, and you can see that there are some triangles that overlap. So let's read the question. Now, the figure below is not drawn to scale. ABC and BCD are two triangles, and the height of the right angle triangle ABC is 2/3 of triangle BCD. So when there's a fraction, what do? We do arrow pointing, right? There's something called arrow pointing. The numerator points to the first triangle, which is 2 units, and the denominator points to the second triangle, which is 3 units. And the area of the unshaded triangle is 100 cm squared. So what's the area of the entire figure? Okay, so you can see that it's a little quite hard, right? It's a bit hard to solve, especially when there is no particular method that we have. So when you see triangles or any shapes, whether it's a rectangle or even a circle, if they overlap, then what do? Then we will use something called ABC method, right? There's something called ABC method. So I call it my own way, right? This is my own term. This is my own name, my own label for this method. Why do I call ABC method? Because this is the whole idea, right? You call every part of the figure a letter. So this part of the figure is letter B, and this part of the figure is letter C. And that's called ABC method, right? So you give letters to every part. So to find the area of the whole figure, then how do we do that? All right, so you can see this is a triangle, right? It's a triangle question. So you will need to find the area of triangles. So how many triangles are there? Of course, you can see there are a few triangles, but there are two important triangles, which the question says. So what are the two important triangles that we are looking at? Which is this triangle, right? And the other triangle, which is the bigger one. Okay, there's a bigger triangle that you can see. So let's look at the first right triangle. Okay, the first right triangle, and what do I call it? I call it A and B. All right, A and B, which is the right triangle, the first right triangle that we highlighted just now. So what's the area of this right triangle? So you have half times base times height. So you will need to know how to find the area of triangle using the formula half times base. And what's the base of the triangle? There are two markings there to tell you that they are the same. Okay, the two sides are equal. So half times 20 and times 20. All right, so use your calculator and you will get 200 centimeters square. Right, so the area of A and B is 200 cm squared. And then how about the other triangle, which is your B and C? So how do you find the area of this other right triangle? So again, you have half times base. What's the base? The base is 20, and there's a problem. What's the height? We don't know what's the height. So we will need to find the height. And where's the height of this right triangle? Or let me use a blue color to highlight. So what's the height of this blue triangle? So to find the height of this blue triangle, you can actually take a ruler. Okay, take a ruler to put on the base. So this is my ruler. And I actually put the ruler onto the base of the blue triangle. So if you're confused about where is the height, then you just put the ruler on the base and you move the ruler along the base. And you look for a line that's parallel with the ruler. So is there any line that's parallel with the ruler? So do you think that's the height? Do you think 20 cm is the height of the blue triangle? Which is not possible because the blue triangle is quite tall, quite high, right? Quite high, or quite tall, right? Quite tall. So where is the height? So if I move my ruler a little bit more to the right until the vertex, right? Some of the students, they learn something called vertex, which is the tip of the triangle. And from the tip, you draw dotted line downwards until the ground level, okay, until the base, and that will be the height. So the dotted line is the height, which is right angle to the base. So how tall is the height? Okay, then you have to look at the fraction, right? The height of the right angle triangle ABC is 2 units, right? The height of the right angle triangle ABC. So where is the right angle triangle ABC? Which is the smaller triangle that you see, right? Which is this triangle that you're looking at. So this is your triangle ABC, and that is 2 units. And the height of the triangle BCD, which is the blue triangle, right? The blue triangle that you saw, that is 3 units. So can we find how high is the blue triangle? Yes, we can, because 2 units is equal to 20 cm. So your 1 unit will be 20 divided by 2. So your 1 unit will be 10 cm. So the height of the blue triangle must be 10 times 3, 30 cm, right? 30 cm. Okay, so we know the height of the blue triangle. So can we find the area of this blue triangle, which is B and C, right? B and C make up the blue triangle. So half times base times height, which is 30. Okay, so use a calculator and you work out and you will get 300 centimeters square. So the area of the blue triangle is 300 centimeters square. Okay, so how do we use the ABC method, right? Number one, right? First step is to put letters into the parts of the figure. Step number two is to write out your statements, your ABC statements. So have you written all the ABC statements? If you look carefully, the area of the unshaded triangle is 100 cm square, which is letter B, right? Letter B is the unshaded, that is 100 centimeters square. So which means that I can find a lot of things. I can find what is the letter C, what area is C? Because B is 100, then C must be 200, okay, 200 cm square, right? And if B is 100 cm square, then A must be 200 minus 100. A must be another 100 centimeters square. Okay, so that's the purpose of the ABC method, right? So ultimately, you are going to find the area of each part, right? What is the area of each letter? Okay, so what's the area of the entire figure? Then you have A plus B plus C, right? The whole figure is A plus B plus C, which is A plus B plus C, all right, which is 200. So when you plus them together, you will get 400 centimeters square, which is the area of the whole figure. And that's how you use the ABC method, right, to solve this problem. And when do I use the ABC method? When you have shapes that overlap. Okay, when you see shapes overlapping and you don't quite know how to solve, then you think of the ABC, right? ABC. Okay, so so let's look at another example, all right, another example, and now it gets a little harder, right? But every time I see overlapping, right, shapes that overlap, then I will always think about the ABC method, right? There could also be other ways of solving, but the first skill, all right, the first method that will come to my mind is, how about we use the ABC method to solve this problem because there's overlapping. All right, so let's see how we apply this method again. The figure is made of 3 identical triangles. And each identical triangle has an area of 240 meters square. And the area of the whole figure is 630 meters square. So what's the shaded area? Okay, so what do? Then I will call every part of the figure, right, with a letter. I call every part by a letter. All right, then what do we do next? So the first step is to label the parts ABC, and then the next step is to create your statements, right, using the ABC, right? So let's find the area of this triangle, which is A plus B. So A plus B will be 240 meters square. And then there's another identical triangle, which is B plus C. So B plus C will be 240 also meters square. And then the bottom triangle is also identical, which is your B plus D, and that will be 240 as well. Okay, right? So that's how you create the statements. So the important thing is whether have you created all the statements? Is there any more statements that you can create? Because if there's some statements that you did not create, you'll find that you will get stuck. So is there any more statements we can create? Yes, we can. The area of the entire figure, which is A plus B plus C plus D. All right, so there's one more statement because without this statement, you will find that you will get stuck. So use the question, right? Use the question to create the other statement. So the area of the entire figure is 630 meters square. Okay, then what do we do? All right, then how do we continue from here? Okay, then you have to study the statements. All right, look at the statements. Right, then you look at the statements and you make a clever guess or an intelligent guess. All right, so I have all the statements already. So what can I do next? So one of the cleverest guess, all right, one of the ways that we can continue doing is we can add up all the letters together, right? We can add up all the letters together. For example, A, right? A, there's only one A. Okay, then you add up all the B's. So 3 B's. So you plus 3 B's and then plus C and then plus D. So you add up all the letters together. And of course, when you add all the letters together, you have to add up the numbers together. So 240 plus 240 plus 240, that will give you 720, right? So you add up all the numbers together also. And then what do we do next? And then you subtract. Okay, you minus to get rid of all the letters except one letter. So you take A minus A, you have no more already. 3B minus 2B, 3B minus 1B, you will get 2Bs. And then C minus C, there's no more C. Then D minus D, there's also no more D. And then 720 minus 630, you will get 90. So what's B? What's the area of B? So 90 divided by 2, the area of B must be 45 cm squared. And that is your shaded. Okay, that's your shaded area. So you solve the problem, right, using the ABC method again, right? ABC method. So you can see that without the method, it's quite hard to solve. If you don't have this, if you are not aware of this particular method, then you'll find that you will need to think harder to solve. So you can see that over here, what is the process of using the method? You have to give letters to every part of the figure. And then you have to create your statements with all the letters, and you have to create the statements, and you cannot miss out any statement, because if you miss out any statement, what happens? You will get stuck. So how to not miss out any statement? You have to look at the question and use the question also to help you to create the statement, like the area of the whole figure. So what does that mean? It means you have to add up all the letters, and that is the area of the whole figure, right? So you have to create enough statements, right? Enough statements for you to compare later. So after you created all the statements, then what do? You have to play with the statements, right? Manipulate the statements so that you only find the letter B, which is the shaded area, right? That's how you play with the statements. So it may not be easy, right? This may not be easy, but it will help you to start somewhere, right? Even though you may not get the answer, but as you go through the process, you find that, well, it might be a bit hard to play with the statements, but as you keep doing, it's actually quite fun, right? Quite fun to finally get the answer later. But otherwise, even if you don't get the answer, the meta marks will still be there. You will still get the meta marks because of the method that you are using. Okay, and what method is that? The ABC method. Okay, so let's go on to the next type of method. All right. The next type of method is also a very important skill, very important method that you need to know in order to do hard questions like this. Okay, for example, like this. Okay, now in the figure below, the rectangle is divided into 4 triangles. The area of triangle A, B, C, 300, 225, and 100 cm square. What is the area of triangle D? So many students, they will get lost. Okay, they will get confused. They are totally puzzled by the diagram, and they won't know how to get the letter D, the area of D. So there is a method here, and the method here is to know how to draw a right angle triangle. So whatever triangular shapes you are given, you must be able to know how to draw a right angle triangle. For example, if I have a triangle that is something like this, okay, which is not a right angle triangle. How do I draw a right angle triangle that is the same area as this triangle? So I just have to draw the same base, okay? And the height of this triangle is the dotted line. So because I want to draw a right angle triangle, I just have to shift the dotted line to the corner to form a right angle, and then I will have a right angle triangle already. And these two triangles are different shape. I mean, they are different. They look different, but they have the same area. Why do they have the same area? Because they have the same base and the same height, even though they look different. So this is the method here to know how to draw a right angle triangle. And not only that, you also need to know how to combine triangles into a right angle triangles, right? So like for my example here, like if you look at this drawing that I've done, I have redrawn a triangle into a right angle triangle. But I can also combine a few triangles together and redraw into one right angle triangle. Okay, so let's look at the example. Let's look at the question, and then you'll have a better understanding on what I'm talking about. Okay, if you look at this ABCD, right? And if you look closely enough, you will see that there are two triangles, one above the other. Okay, these two triangles. So I am going to draw a right angle triangle, just one right angle triangle, which has the same area as the two red triangles combined together. So how do I draw a right angle triangle that has the same area as these two red color triangles? Okay, this is how you do. Now, you just have to draw the same base. If you look at these two red triangles, what do they share in common? They share a common base. Look for something common. If you see a few triangles, and what do they have in common? They have a common base. Okay, common base. All right, then how tall is this right angle triangle that I'm going to draw? Well, if you look at the height of these two red triangles, the first triangle, the height is here. And the second triangle, the height is here. So when I join them together, it will be something like this, right? And I draw the height at the end of the line to form a right angle. And then you can now see that this is a right angle triangle that has the same area as these two triangles, which I'm highlighting. See? So the right angle triangle has exactly the same area as these two blue triangles. And that is my area A and C. So what is area A? Area A is 300, right? And C is 100 centimeters square. Okay, now what is the purpose of drawing a right angle triangle? What's the purpose? Now, the purpose of drawing a right angle triangle is so that you can create a rectangle, which is similar to what you see on the left side. Okay, yeah, that's the purpose of why we create a right angle triangle, so that we can form a rectangle or sometimes a square with another right angle triangle. So the other right angle triangle is also the same area, and that must be your letter B and D. Okay, all right. So if my letter B is 225 centimeters square, then what is my letter D? Then that'll be quite easy to find, because this area, right, this A and C together is 400. Okay, 400 centimeters square. Then the other right angle triangle must also be the same, which is also 400 centimeters square. Then you take 400 minus 225, and you get the area of part D, which is 175 centimeters square. And that's how you get the area of triangle D. So yeah, 175 centimeters square. So what's the method here? To know how to draw a right angle triangle, to know how to redraw a triangle into a right angle triangle, and also to know how to combine a few triangles that may share a common side, right? If the triangles share a common side, then we can also redraw them into a right angle triangle. Okay, yeah, so these two triangles that you see over here, okay, I'm going to just show one last time. The green color triangles, right? And what do they share in common? If you look carefully at these two green color triangles, they share a common side. And what common side? The base. Okay, they share the common base. And because of that, I can join them. I can combine them into a right angle triangle, right? Sometimes they share a common height, sometimes. And I can also use the common height to draw into a right angle triangle, and then can solve already. Okay, so using the same method, right? Let's look at another example, the last one, and it gets harder. But the method is still the same, right? Still the same thing. Now the area of the rectangle below is 96 centimeters square. Yeah, so the entire area is 96, right? And the area of triangle ACS is 27. So where is ACS? Over here. This is the area of the triangle, which is 27. Okay, let me just put 27 there, centimeter square. And find the sum of the area of the shaded triangles. All right, you can see that there are some shaded portion. So how do we find the area of the shaded portions? And we only have two numbers there. Okay, now So once you understand the method, how to draw a triangle into a right angle triangle, you use that to solve this problem. Okay, so how do we do? Okay, now I'm going to erase the green color. Okay, erase the green color. And we just focus on one of the big triangles, which is this one. Okay, let's focus on this big triangle, which is not a right angle, right? This is not a right angle triangle, but can I redraw this into a right angle triangle? Yes, I can. I draw the same base, okay, same base, and the height, okay, the height of the right angle triangle, how do I draw the height? Will be here. This is the height, okay, the height, okay? Because why? Why is that the height? Because when you look at the right triangle, the height is here, right? The height. Okay, that's where you see the height of the right triangle. So instead of drawing the height inside the triangle, inside like that, I shift the height to the left side, so that, all right, so that the height is joined to the base. Okay, the height is, all right, is at the end of the is at the no is touching the base to form a right angle. Okay, that's the height. That's how I draw the height to form a right angle. And then I join the two blue lines and I have a blue triangle, which is a right angle triangle. So that blue triangle is the same area as the red triangle, right? And what area is that? Do we know what area is the blue triangle? Yeah, we can find the area. Because why do I draw a right angle triangle? So that I can form a rectangle with another blue right angle triangle. So to find the area of one blue triangle, I just take the area of the rectangle and I divide by 2, I get 48. Yep, so the area of the blue triangle is 48 centimeters square. Okay, all right. And isn't the area of the blue triangle the same as the red triangle? Okay, so let's erase all the colored lines. So now we know that the area of the blue right angle triangle is 48. And the area of the blue right angle triangle is also the same, right? It's also the same area as the red triangle that we highlighted earlier on, right? So when we draw this red triangle into a blue right angle triangle, what's the area of the blue right angle triangle, which is 48 centimeters square? Okay, so this red triangle is 48 centimeters square, and the area of triangle ACS is 27 centimeters square. So I just take 48, which is the area of the red triangle, and I minus 27, okay? And I will get 21, which is over here. So this is the 21 centimeters square. Okay, and then what do I do next? So how do I find the area of the shaded triangles? So how do I find the area of the shaded triangles? Do we know what's the area of this unshaded part? Yes, we can, because this other, okay, look at this other triangle. All right, by now you should know that this other triangle is what? Can also be redrawn into a right angle triangle. Is also half the area of a rectangle, right? So this blue triangle is also half the area of a rectangle. So which means that I just take 48 again, and you minus 21, and I get 27. So the question mark over here is 27 centimeters square. That's the question mark, right? So that's the unshaded portion. All right, so how do I find the area of all the shaded triangles? How do I find the area of all these shaded triangles? I add up all the unshaded, which is 27 plus 27 plus 21, and I get the total unshaded. So 27 plus 27 plus 21, I will get 75 centimeters square, which is the unshaded. Then I take the total area, which is the rectangle area, and you minus 75, and what do you get? So 96 minus 75, I get 21. So the area of the shaded triangles is 21 centimeters square. And that's how you solve. Okay, so how do we solve this problem? We have to know how to draw, how to recognize the triangles, and how to redraw them into a right angle triangle. So why do we need to draw them into a right angle triangles? So that we can form a rectangle with another equal right angle triangle. And that's why once we can draw into a right angle triangle, you can see that the steps will be quite easier to find. We'll be able to solve it already, right? So these are the two important skills that that we can think about, right? When we see picture clues, right? These are picture clues. What kind of picture clues? Overlapping, right? Overlapping is a kind of picture clue. So when we see something like that, we use ABC method. And if we see triangles in rectangle, right? If we see triangles in the rectangle, and even the earlier problem, you can also see that there are triangles in a rectangle. These are picture clues. So when we see all this, when we recognize these picture clues, then what's the method? Then we will draw a triangle into a right angle triangle. So picture clues. So when you do area and perimeter, you have to look out for picture clues. Like when you solve word problems, you look out for clues in the story to find what method to use. Likewise, when you look at pictures, right? Pictures, you have to look for clues in the pictures to tell you what method that you can use. Okay, so we come to the end of this short lesson on spatial visualization. There are still other types of skills that we can learn, but just for today, I'm just talking about these two important skills. All right, of course there'll be others as well. But hopefully these two skills will be enough for you to solve some of the hard problems. All right, so stay tuned to the next Zoom recorded session. I'll be talking about another kind of heuristics. So that'll be on next Friday. It'll be recorded. So I will post it at about on Friday about night time, right? Maybe about 8 p.m. or later than that. All right, somewhere at night. Okay, so that's the end of the mini lesson. So I will see you in the next recorded session. All right, so goodbye.